Cell regeneration. Cell generation can be physiologically regeneration, e.g. enlarged epithelium, involving cell division for the replacement of cell lost naturally. It can also be pathological regeneration, e.g. cells and tissue injury, the replacement of the lost parenchymal cells by division of adjacent surviving parenchymal cells to restore injured tissue. Cell regeneration is determined by the proliferative capacity of injured cells. To understand cell proliferation, it is important to learn about the cell cycle and its regulation. The key processes in the proliferation of cells are DNA replication and mitosis. The sequence of events that control these two processes is known as the cell cycle. The cell cycle contains a series of steps at which the cell checks for the accuracy of the process and instructs itself to proceed to the next step. Because its central role in the growth regulation, the cell cycle has multiple control. The cycle consists of pre-synthesis growth phase 2, the DNA synthesis phase, the pre-mitotic growth phase, and the mitotic phase. Non-dividing cells are either in cell cycle to enter a phase called G0. Any stimulus that initiates cell proliferation, such as exposure to growth factor, needs to promote the G0, G1 transition, and the entry of the cells into the first G1 phase of the cell to transverse the intrinsic quality control mechanism for cell integrity, known as checkpoint control. Checkpoint control prevents DNA replications or mitosis of damaged cell, and isotransiently stop the cell cycle to allow for DNA repair or eliminate irreversibly damaged cells by apoptosis. Progress through the cell cycle from G1 is regulated by protein called cyclin, which form complex with enzyme called cyclin-dependent kinase, CDK. CDK work for promoting DNA replication and the various aspects of the mitotic process, and are required for cell cycle reprogression. CDK are suppressed during G1 by multiple mechanisms. A major action of the growth factor is to overcome these checkpoint controls by releasing the suppression of CDK activations. Once cell enter the S phase, the DNA is replicated, and the cell progresses through G2 and mitosis. The ability of tissue to repair themselves is critically influenced by their intrinsic proliferative capacity. Based on this criterion, the tissue of body are divided into 3 groups. Continuous dividing tissue, labile tissue. Cells of this tissue are continuously being lost and replaced by maturation from stem cells and by proliferation of mature cells. Labile cells include hematopoietic cells in the bone marrow and the majority of the surface epithelium, such as the stratified squamous surface on the skin, oral cavity, vaginal, and cervix. The cuboidal epithelium of the ducts draining exocrine organs, such as salivary glands, pancreas, biliary tract, and the columnar epithelium of the gastrointestinal tract, uterus, and the fallopian tube, and the transitional epithelium of the urinary tract. This tissue can readily regenerate after injury as long as the pool of the stem cell is preserved. Stable tissues. Cells of these tissues are quiescent and have early minimal replicative activity in their normal state. However, these cells are capable of proliferating in response to injury or loss of tissue mass. Stable cells constitute the parenchyma of most solid tissue, such as liver, kidney, and pancreas. They also include endothelial cells, fibroblasts, and the proliferation of the cell is particularly important in wound healing. Stable tissues have a limited capacity to regenerate after injury, with the exception of liver. permanent tissue. The cells of this tissue are considered to be terminally differentiated and non-proliferative in post-nano life. The majority of the neuron and cardiac muscle cells belongs to this category. Thus, injury to brain or heart is irreversible and result in a scar because neuron and cardiac myocytes do not divide. Limited stem cell replication and differentiation occurs in some area of the adult brain, and there is some evidence that heart muscle cell may proliferate after myocardial necrosis. Nevertheless, whatever proliferative capacity may exist in this tissue, it is insufficient to produce tissue regeneration after injury. Skeletal muscle is usually classified as a permanent tissue, but satellite cell and endothelial sheaths provide some regenerative capacity for this tissue. In permanent tissue, repair is typically dominated by scar formation. With the exception of tissue composed primarily of non-dividing permanent cells, such as cardiac muscle and earth nerve, most mature tissue contain variable proportions of three types: continuously dividing cell, quiescent cell that can return to the cell cycle, and non-dividing cell. In this manner, extracellular mechanical forces can be coupled to intracellular synthetic and transcriptional pathways. That's all for this section. Thank you.